Right, good morning. We're continuing adding, subtracting fractions. Rational expressions, actually. Technical name for it. Let's recall what we did yesterday. We started off with the easy questions. Why? Because they all had common denominators. And as you know, to be able to add and subtract rational expressions, we need to have common denominators. Those denominators must match. All you did was add up those two numbers and copy one of these common denominators here. And eventually you need to reduce though. I get 7/4. You can even do this with variables. We did that with this one, for example. We copied one of the denominators as long as they match. And we copied the tops, right, 9x, and the sign between them. We discovered a mistake at this stage. What was the mistake? This is wrong. Yeah, you either put the parentheses at this stage and pass this minus and flip these signs to minus and plus, or do it quickly right here and make this is already minus and make this one a plus. Flip both these signs. This becomes minus x, this becomes positive 9. Okay? You either do it right on the spot or put the parentheses, do it next. And this was also easy to type because its denominators already matching. The problem with today's questions is none of these denominators are given automatically equal. They are not equal. 3m, 9 different. 7m, 6 to the n to the 6 is not even close to this one. Or these two completely far apart. So what do we do? So first recall how we do this in easy example here. Let's try to make sense out of what's done here. Once you're given two different denominators, you need to look for a way to make them the same. That's called getting common denominators. We need to get common denominators. To achieve that, you need to break means factor all denominators into simplest factors. They haven't done here because they automatically seen what's missing in each side, but technically you need to break 10 as 5 and 2, and 5y is already 5 and y. You can't break them further, and see what's not matching in each side. We already have 5's matching, but this side has an extra 2 which is absent on the right, and on the right you have a y extra which is absent on the left. So in other case, left side is missing y, so I covered what's matching already. What's not matching is 2 and y. Left side is missing y and the right side is missing 2, and you make up for those by multiplying both sides, y on the left and on the right, both sides multiplied by 2. So whatever is missing, you pretty much multiply top and bottom with those items. That's it. And then when you do that, you see these denominators matching. Get that common denominator combined and only add the tops. Add y and 24 and simplify if necessary. Okay, this procedure is called getting least common denominator, least one, because you could have got 20y and 20y here. It's also common denominator, but it's not the least amount. Least amount they match quickly is at 10y. Such as if I multiply here by 2y's and these by 4's, I would get 20y and 20y. But it's not the most economical one. It's waste of numbers. You met in a larger value than it's supposed to. Okay? So this, but when you do the procedures I did, break up and see what's not matching and multiply, you will always get the least common denominator. It's called shortly by LCM. LCD, least common denominator. I will explain this in more detail in these questions, okay? And here are the steps again. Alright, step 1. Step 0. Check whether you have those denominators already matching. Are they matching 9 and 3m? No. Then do these steps. Step 1. Factor both those denominators. Factor 9. Can you break 9? 3 and 3. How about 3m? It's already both pieces are simple. So it is 3 and m. Okay? Next, we need to get LCD, least common denominators between these two. Least common denominators. Alright, I need to see what's already matching. What is already matching? And uncover them if necessary. So I will take a color pen and whatever is matching, I will cover them. 3 is matching on each, so I will cover it. And what's not matching is we have an extra 3 on the left and we have an extra m on the right. Alright? So I need to get one m here, missing m. This one is missing an m. And this one is missing what? 3. If I put m here and 3 there, they will both be 3m and we will be happy. They will be matching. Okay? So to make this missing m though, you can't just put it magically here. You need to do the same thing to the top as well. You need to put that same m to the top as well. To make this missing 3 here, you not only put 3 to the bottom, but also you put 3 to the bottom, top. Okay? Now before the next stage, don't forget to uncover what you did here. These things did not disappear. We just covered them for temporarily. You need to make them visible again. So what was under this? It was 3. So take back what you did. There was still 3 there. Okay? Now look, 3, 3m, 3, 3m. So we have a common denominator now. What is it? Multiply them back again. 3, 3m makes 9m. 3, 3m makes 9m. 3 times 3 is 9. But the tops are 7 and 5, correct? Original tops. Am I right? No.
7m plus 15.
Yeah, this top gets a new green m, so it becomes 7m. And this top gets a brand new 3 next to it, so it's 15m. 15 only. Sorry, not m. Now check again. Do you have a matching pair of denominators? Is this a match? It's a match, right? So we have a common denominator. You can combine these two back here, right here. And what do I do with the tops? We simply put all these 3 together, 7m, 15, and the sign between right here. And if possible, add 7m and 15. Is it possible to add these up? No, they are not like one has a variable, the other one is a constant. We cannot add them. Can we simplify this further? We cannot simplify this further in... Maybe we can. Can't we cancel m's? I think we can cancel m's, right? Can we? Make that 7 plus 15 over 9. Can I cancel them? No, we cannot cancel them. Alright, because this 7m is a block together with 15 addition sign. Make sure the sign after m is not addition or subtraction. If there is a plus or minus coming on before and after what you're supposed to cancel, then you cannot cancel them. It's a block. So this is your final answer. Alright, we're continuing with the next one. Right here. Same deal. First off, I will break everything on the bottom if possible. But can I break 7? No. Can I break m? No, it's already a letter. Do we need to break 6 to the m, make it 6 n 6 times? Totally unnecessary. You don't have to break it. Keep it as it is. You know already this is 6 times n itself. Alright, you don't have to show off, okay? How about 21? Can I break 21? Yes, you can. This is breakable. 21 is 7 and 3. N to the 5th is 5 n's together. Okay, start covering the same items so you can see the differences better. I mean, this is optional. You don't have to really color them, shade them, but I like doing it, okay? So I will shade the stuff that is already common. So 7 is already common. I will cover off these. Alright, what else is common? N to the 5 is common. We have 5 n's here, but this has an extra n. So if you don't mind, I'm going to expose that extra one here and reduce this to the 5th. This one has one more extra. This one. 6 means you have one more n extra. So these will cover now. They are match. So what is extra here? Whatever is extra here than this one, which is not covered, you need to put it here as missing. So this has missing what? M and N together. Let me put them in red. M and is missing because they are present on the left. This one has none. What is this one missing? What is on the right already uncovered? And this is missing. It's just 3. So how do you make up for these missing things? Whatever you spotted missing here, you need to put it to the both sides. 3 to the bottom and top. And whatever is missing here, you need to multiply bottom and top with it. By the way, where is the top of this thing? 4m already on the top. 4m gets brand new 2 more items next to it, m and n. Is it clear? Alright, let's multiply everything together and put it here. When you are doing that, you need to take all this stuff collectively and put it here. So it was 7 under this box, 7. Together with 3, 7 and 3 makes 21. It's no longer 7 then. Look. There is 7 here and 3 more multiplies it and it makes 21. We have only a single m and nothing new comes to it, so it's m. How many n's do you have? 5th, one more 6 n's. And that's it, right? 21 m n to the 6. Let's do the same justification here. 3 times 7 is 21. We have 5 n's, but one more joining into group. We have 6 n's. And then a single m. Did we get the same denominator? So when you're doing these multiplications, don't cheat from the other side. Always do a brand new multiplication. If you're getting something different, that means you did some step wrong earlier. Go fix it. So when I get these two the same, I'm relieved. Oh, I did everything right. So I got the common denominators. How about the tops? You need to compute them. 3 times 16 is 48. And this makes 4 double m combines into m squared and a single n. All we gotta do now is combine these two with the same denominator. They share the same denominator, so you make one of them. Top will be 48 and 4 m squared n. Okay? Now I will look for cancellations here. Try to factor and cancel, add things. I see 4 is common. I can pull it, factor it out. This is 4 times 12. This is just 4. I can factor that 4 out. But when you factor that 4 out, is it possible to cancel that 4 with something from the bottom? Well, the bottom is 21. So if there is no cancellation in future, you don't have to break. You don't have to factor. Although this looks like factoring, I'm not going to do it because it's not canceling anyways. So I will just enter this answer to my solution as my solution. This was 4m squared, right? Good. All right. Are we good so far? We're gonna get faster. I'm doing this in baby steps, but you should be able to get faster and faster. We don't play this coloring game too long, okay? All right. How about this one now? Number 7. We need to first factor things. Only factor the denominators, not the tops. Tops, don't touch the tops. Top is the same. I'm wondering how I can factor k squared minus 64, and I bet there is a rule for it. Do you recall?
Difference of squares.
Yep. 64 is actually 8 squared. And I can break this k squared and 8 squared, a squared minus b squared rule. Look, I'm not writing those anymore. I'm just applying it because we've been doing this for 2 weeks. You should do this k minus 8, k plus 8. And there is nothing, absolutely nothing to factor on the second one, right? K minus 8, simple. Well, it's just one block of items. One block, 2 blocks on the left, 1 block on the right. We'll play the matching game again. Take your color pen, see what's already matching, cover them, shade them. This is already matching, isn't it? Already here. So this has stuff extra. This has some extra stuff, right? It's not been covered. So that means the other side must get it. This is missing whatever extra here, missing that item. So you need to spot this. This is missing k plus 8 from here. How about this? Is this stuff missing anything? Are there anything here, right here, that has not been covered, shaded? Are there anything that has not been covered, so we need to put it right here? It's just 1, but 1 doesn't count because 1 is everywhere. Even this one has a 1, so it's not really missing it, okay? Other than 1, is there anything missing? No, none. So you don't have to do anything on this side. You don't have to multiply this. Okay? But this one will take this k plus 8 here, and you need to put it to both sides. Both sides, I mean top and bottom. Make sense?
Doesn't have to be in parentheses on the top.
Exactly. I was trying to make a problem here, but you caught it already. When you have a block of items, you're multiplying both sides, like 2 items, k and 8, you need to keep it in parentheses and distribute this 9 to it later, both terms. Otherwise, if you don't put the parentheses here, it just seems like 9 is only multiplying k. So you read it as 9k plus only 8, which is incorrect. Has to be 9k plus 72. 9 times 8 is 72. Not only that, I will make another mistake and watch out for it. But let me first do the next one. Okay, now uncover the shaded areas, shaded stuff, and put this together. And this one, k minus 8 and k plus 8. Are these two the same now? Are they the same? Yes. Even better, you can actually convert this back to what it was. It was this. No, don't do that. Don't do that. Keep it factored, please. Because I like it factored because eventually on the final result, we may need to cancel stuff. If you have things already factored in the denominator, it's easier to cancel, okay? So for cancellation purposes, please do not revert back to this form. Just keep it factored. Next, there is no change on this top, but there is a change on this one. It's 9k minus 72. Now we are going to combine these two fractions into one because they have a matching pair of factors in the denominator. Just k plus 8, k minus 8. All you need to do is bring this top together right here. K minus 9k minus 72. There is a mistake. Let's see who's gonna get it. What? Right. No, it's not a mistake. We are gonna combine it later. It's not a mistake yet. Yes. Remember, what did I tell you? If there is a minus sign, it belongs to both of these guys. You need to pass it to not only minus 9k, you did to minus 9k, but you didn't pass it to minus 72. You need to change the sign of everything on the right side. So this is plus 72. This is the most happen mistake. You come complaining me, oh, I did all the work, Connect Math is not taking its system, is stupid. No, you're making a mistake, okay? Computer is not. It's human mistake. That plus sign is the most mistake, okay? Alright, next, yeah, we need to simplify this by combining like terms. These are like both k's. So you have 1k, take away 9k. How many k's in total? Let's do it here. Minus 8k plus 72 k plus 8 k minus 8. Now I will try to factor top for sake of cancellations, but can I factor the top? Do you see anything common between these two terms? 8 is common, right? 72 has 8 times 9. So I can factor an 8 out and get minus k. There's still a minus there. And 9. However, is there any cancellations happening? You factored it, but did it yield any kind of cancellations? No, no cancellations. So you can stop here. This is your answer. You don't have to do this because no cancellations. Try to enter this one, okay? Or even better, you can put this, revert this back to k squared minus 64. Put your answer as minus 8k plus 72 over k squared minus 64. You don't have to keep this separate. Okay? Again, start with a fraction. Now, put it down. All right, I messed up somewhere.
You have to factor up the top.
They want it to be
Yeah, they want it separate.
okay. So they push us to do that then. They like to see the factored form then. Let's check. Yes, they want it factored. So we got our lesson. They want this factored, please. Don't leave your answer like this. You need to go one more round. But this can be, how about this? Did you check separately? Do we need to multiply this? Let me try the separate case.
They have it separate on the
Okay. Let me check two as well. K plus 8. K minus 8. Let's check. It liked the bottom. You don't have to do anything on the bottom, but they want the top factors. Alright. Huh. This looks like a simple quick question, right? Comparing to this mess. Oh, we didn't solve this. I skipped this one. Sorry. Yeah, there is another one here. So we need to do this first. Oh, this is not easy. I don't like it out at all. First, we need to factor. Factor the bottoms. How do you guys factor x squared plus 2xy plus y squared? Well, that's a tricky one.
difference of cubes.
No, because difference of cubes is this. You need to have third powers. Yeah, you kinda relate. It's related because in difference of cubes you have a square here. Yeah, they kinda resemble like this, but we need to bring this into two parentheses. This is the big one, and it doesn't have a cube, okay? So it's not difference of cubes. This is something else. It's, does anyone know? X squared twice xy plus y squared. Kind of thing like this. It's still factoring. Use your factoring skills. There is two expressions here. They multiply to y squared. You're gonna put something and something here. They will multiply to y squared. But when you add them, no, it's gonna make 1. Just ignore these guys. Ignore the variables. Just look at the numbers in front and ignore this one. You're gonna multiply two items here. It's gonna make 1. But when you add them, it's gonna make 2. You're trying to make 1 and 2. But to be able to get y squared, when you multiply these two, I'm sure each will have at least one y. so that I can get y and y. What will be the coefficients of these y's? It will be 1y, 1y, so when I add them it's gonna make 2. 1 and 1 makes 2. When I multiply them it's gonna make 1. So kinda I guess that it's x plus y, x plus y. But you have seen this formula. This is not the first time you are observing it. So let me go back to chapter 6 and show you that you have seen this before. It's called square expansion. Should be in the late section somewhere, 6.6 or 6.7. There we go, we got it. I told you, you have already done this with x and y. If you have x and y here, these will be x squared, xy, and y squared. Instead of a and b, they are testing you with x and y's. So if you have x squared, 2xy, and y squared, it's x plus y squared. X plus y squared means x plus y and x plus y, doubled. If you have a minus though, it is x minus y, x minus y. Alright? If you have x squared minus 2xy and y squared. Alright, it's called perfect square trinomial addition and subtraction versions. So once we know this is square of x plus y, we can go back and turn this into x plus y and x plus y. And you really FOIL this, x squared, y squared, 2xy is what you obtain. The second half is kind of easier. Do you see this is a binomial, it only has 2 terms. So you just need to look for something common among each term. What is common? X's. So I factor 1x and dump the leftovers here. When you remove 1x from x squared, there is still an x left. When I remove x from xy, only thing left is y. Okay? Now, factoring part is the challenging part here. We are done. We are done with it. Now take your color pen and see what's matching already and cover them. These are matching already. I'm covering these up. Compare leftovers on the left and right now. This has extra x plus y. This has extra x. So this side is missing what? Missing what? An x. Perfect. This guy is missing, so it comes here. And what is missing on this side? Missing x plus y, entire x plus y. Okay? So I will put x to both sides here and x plus y to both sides here. I'm out of screen a little bit, but I will add right next to here, okay? You see that?
Wouldn't that turn out, wouldn't you just add plus y since the x is already there though?
Oh, good question. Alright. So if you have, like, I'm making up x plus y, and this is just x, and you see this has only y missing. So can I just add y to both sides of this equation? Do we have an addition tool, weapon? Now, let me make a simpler expression. This is half pizza, right? You're telling me that you can add anything to top and bottom? Let's add 1 to both sides. You used to have a half pizza. This is your pizza slices, half pizza, right? When I add 1 to both sides, 2/3 is more than half. You have an extra piece now. Your ratio changes if you add to both sides, okay? So you're not allowed to make addition to both sides. This is not allowed. But multiplication is fine. You have a half pizza, you can multiply both sides with any number you wish, like 3. Because this makes 3 6. You still have, out of 6 slices, you're getting 3 slices. It's still half. Right? It used to be half, and I multiplied. This is still half. You preserve the ratio when you multiply. But when you add, it's destroying the ratio. So we're not allowed to. It's smart. It's a good observation. Yeah, why don't we just add y2 here? It already has an x. But you can't add. Add is not our weapon. Alright, next. Let's multiply this out. It's x squared. And bring everything together now. It's x plus y. Another x plus y. And there was a missing x. We made it up and we put an x afterwards. This one is 9x times x plus y. 9x and it took an extra x plus y. And underneath we already had this couple originally. This is original, x and x plus y. But you brought in a new green piece, that's x plus y. Did we get a matching denominator? Did we? 2x plus y's and a single x. Single x, x plus y, it's a match. I'm on the right track. Explain this part so you don't get confused. Alright, next. If you already achieved the matching denominator, take one of them, copy one of them and put it here. But what do I do with the top? Tops needs to be combined. X squared plus 9x and x plus y. Okay? What would you do next? Is this your final answer? No. We must always look for further cancellations. For further cancellations, you need to first combine like terms on the top and factor again and make cancellations. How can I do that? First off, clear all parentheses. Multiply this 9x as 9x squared and 9xy. And the denominator is the same. I'm not repeating it. And I see these are like. Can I combine them into 10x squared? Right? They make 10 of them. 9 and plus 1 is 10. And the denominator, let me write it. Alright, I did all simplifications on the top possible. I combined like terms. I ran out of bullets. This is the last thing I'm gonna do. Is there any factoring going on the top, so maybe we can cancel with the bottom? Do you see any kind of factoring happening on the top?
X out.
Yes, we can. There is an x common. We can take that x out. What is left is 10 here and another x, because this is double x. Square means double x, so we have another x left over. 9 is left and y is left. Alright, you did factored this. However, did it work? Do you see a matching piece on the top and bottom that can cancel? Yes, there is. There's something you can cancel. What is it? X. Well, can I really cancel a single term? Usually I said blocks. Beware of blocks. It may be a block. This is not a block, because the operation before and after x is multiplication with the rest of the items. So this and that can cancel because it's multiplying. It's not adding. If it was an addition, yeah, we were in trouble. We couldn't cancel it. But it's not addition, it's multiplication, so we can cancel x's. How about x and y's? Can we cancel these like that? Can I? No. These are addition. You see, after x I have an addition. They are block. These two parentheses must match entirely or else. We cannot cancel them. We cannot cancel else. Okay? So this is it. This is my final answer. 10x plus 9y as a block, and x plus y and x plus y as a pair. If you like, you can turn this into square. It's x plus y squared because it's repeating itself. But it's not necessary. It's your choice. Alright, time to face the truth. Did we make any mistake? Any mistakes we did? I don't know. Maybe there is. It's 10, what? 10x 9y x plus y squared. Do you want to keep it separate? I will combine them. X plus y, I will make a square. How did that happen? Okay. Good. Any questions? Look, you're gonna get frustrated in these questions a lot. You won't get this answer in one shot. Okay? It's okay. It's fine. Bring your work to me. I can spot your mistake. But I need something on paper, okay? So don't waste too much on it if you're not getting the right answer. Alright. We're kinda taking a break and investigating an easy question. Why, look at this. Only 5 in the denominator. But can we say this? Oh, they are already matching us. Can we combine these two? Are they matching though? No. One is a plus, the other one is a minus. There is an easy fix for this. You don't have to think too hard for it. If denominator is almost matching, the only difference is a sign, take the negative one. Okay, and bring that negative to top right in front of this fraction and combine with whatever sign it has there. Combine these two signs. Bring it to the top and combine signs. So what happens if you combine a minus with a minus? When you multiply a minus with a minus, what happens? They turn into plus. So these two will make a plus in between, and this will be perfect plus 5. So what I'm saying is this ratio is actually r over 5 doesn't change, but the sign in the middle turns into plus. As I said, it turns into plus, and we like pluses better than minus, and the denominator lost this minus and turned into plus, and the top is still the same. Now look at how simple this question is. Matching denominators. So we can combine, and all you need to do is bring all these three together. R plus. Any sign change needed? If this is a plus, you don't have to change signs. If it's a minus, you change both though, but not now. Okay? Next. These are like, we can combine them. They combine into 5r minus 7 and 5. Alright. I'm looking for a factoring on the top. Any factoring going on the top? No, right? 5r and 7 has nothing common. But at least can I cancel these? Can I cancel 5s? I don't remember how many times I made this mistake since the beginning of this section. Or even last classes, I mean previous chapters. But no, we cannot cancel this. Oh, you may say, what? Wait a minute, this is a multiplication? No, technically 5 and r are together. So you need to just go skip r and check out the next line. It's the next operation is subtraction. So 5 is not separable from this group. This is a block. So you cannot cancel 5s again. Don't cancel them. Okay? However, if you wish, you can do this. You can split this fraction into 2 pieces, like 7/5. You distribute this denominator into 2 pieces. Then, yes, now you can cancel these and get r minus 7/5. This is okay. But you need to separate this 5 in 2 ways, then cancel this. Now 5 and r in product form. This is independent from this. They cancel. However, this is not necessary. This answer is acceptable here. You don't have to do this. Okay? I want to test if the system is smart. I'm going to enter my new reduced form. It didn't like it. It's not smart then. R minus 7/5 is what I get here, right? Mathematically this is correct, but it's just computer is not that smart. So instead we need to try the earlier version. What was it? 5r minus 7 over 5. It liked this one better. Okay, don't split apart. Don't do this. It's correct, but it didn't like it. Stop here. If it's not factoring, don't break up apart. Any questions? Alright, now this actually brings up again the same misconception. When I test you on this with the exam brush or something, you feel like, oh, this is only missing 8. I want to add 8 to both sides, right? You have this urge, right? Come on, it's just missing 8. Can't we just add 8 to this guy? The answer is again, no. You can't do that. You don't have the addition operation available to you. You can't add things to both sides. Pizza example again. You have half pizza. Can I add more slices to each plate? No. Top and bottom, you can't. The ratio is broken. So addition is not right. You need to do this. Factor. Can we factor x and x plus 8? This is a simple question. Can you break x more? X plus 8 more? No. Now we need to start coloring. Is there anything matching here?
You just have to do the same thing as you did before, but adding x plus 8 to the left and then adding x to the right.
Right. We are going to do that, but I'm still want to test your misconceptions. So these are matching. Does this mean we can color it, cover it, and 8 is missing? So can I just multiply both sides by 8 this time because this is missing on this side? Again, no. We cannot take this axis separately because this is a block. So I really insist putting on parentheses here. These cannot be treated separately. They either match entirely. You need to have the exact x plus 8 here to cover them, or you cannot color them. So this thing is missing. So there is nothing matching here. No match. Although x is like kind of matching, no. There is nothing matching in this denominator. This entire x plus 8 is missing on this side. And this entire x here this entire x is missing on this side. So you need to put both sides those items. So this one will take x plus 8 on both sides, and this one will take x on both sides. Do you get it? So this is what one of the scariest questions actually, because it looked like easy. Everybody falls into trap. Everybody goes into this trap. They make so many different mistakes. So it's easy looking questions actually the hardest questions in math sometimes. So now we have, let me rewrite this, 6x plus 8 on the top, x plus 8 on the bottom of the first fraction. The second one is 4 and x plus 8 and x. Do we have a matching pair of denominators here? Common denominators? Although in reverse order, yes, they are the same. So we can combine and pick one denominator as you wish. I picked the left side. And we need to multiply this out technically and add 4x to it. Oops, what did I do? It's 4x, right? It's not double 48. And combine like terms and factor. When I combine these, they make 10x. Alright, any factoring going on the top? Break 10. Break 48. Do we need to break 24 further? Yes, if there is a possibility of further matches, but I don't see any more possibilities because already 2 is matching, and 5 and 24 has nothing in common. So I will only factor 2 and leave out 5x and leave out 24. Alright, I was hoping for some cancellations going on, but it didn't happen. This is our final answer. Okay? Are we good? So this is a really big section. I'm taking my time because I know this section is nightmare for most of you guys. We spent already 2 hours on it and we will go for another half hour next time. But
can you type in 10x plus 48 since there's...
I don't think so. I think it's not gonna like 10x version. You need to factor, but let's try. So if you type in this one, it's gonna say incorrect. You need to go with the bottom. But let's try. 10x plus 48 divided x plus 4. Check. It says incorrect because they want us to factor. Let's factor. Oh, let's try again then. Thank you. Hey, it liked it. I don't know why it didn't like earlier, but sometimes it likes, sometimes it doesn't. But technically, to be safe, factor this guy please 2 and make it, oh, I messed up. 2 x plus what 24, right? Was it? No, it was 5x. 10 is 10. It was 10, so there's still 5. It lacked this one too. So this is the safest option, but sometimes it lacks the earlier version as well. Alright, we're done. Make sure you sign up.